Okay. Hello, everyone. My name is Bartek, and I'm working as a senior manager of cloud engineering at Pegasystems. And today, I'm going to be talking about resiliency, which is not very surprising by the title of this presentation. I'm going to be talking about resiliency in context of chaos, in context of clouds, and in context of particular tool that allows you to inject different kind of disruptions to your systems. And this tool is obviously called AWS Fault Injection Simulator. Before we start, how many of you have heard about chaos engineering, the term itself? Hey, quite many. And who is really using this approach? One person, if I'm counting right. So, and by the way, one more question. AWS Fault Injection Simulator, anyone had a chance to play with it? One person. Great. So, you know, at least someone was playing with it. So, my purpose of this presentation, in fact, there are two purposes of this presentation. So one is to give you some overview what chaos engineering is. That's the one thing. But for those who knows already, I would like to give you some answers to the questions that you might get from your stakeholders. So basically, if you're convinced that you would like to do chaos engineering in your organization, usually you're gonna get some questions from business, from stakeholders, from your PO, from your manager, from CEO of the company, whoever. So one of my purposes is to give you answers why it's worth to do chaos engineering. So this is a theory about this approach. The second purpose of this presentation is to give you a taste of AWS Fault Injection Simulator. So a tool that really gives you a possibility to introduce chaos engineering easily for your cloud system hosted on AWS. And of course, don't expect that it's going to be very detailed presentation about capabilities of AWS Fault Injection Simulator, because we cannot do that in 50 minutes. But what I would like to try to do is we're gonna be doing a small chaos engineering tests against very, very simple architecture. And we will see how it's gonna end. So before we start talking about chaos engineering itself, one slide about chaos theory, which is basically a fundamental of chaos engineering. Who knows the movie? Three people. Come again? Jurassic Park. The first one and original Jurassic Park. And this particular scene is exactly about chaos theory. So the guy you can see on the screen, his name is Ian Malcolm. And in the movie, he's a mathematician specialized in chaos theory. And what he's doing here, he's actually explaining that to the paleontologist. So the example that he used was based on drop of water. So basically, if you put a drop of water on your hand, this drop of water is gonna fall down through some path on your hand. If you do that once again, the expectation might be that it's gonna be following the same path, but actually it might not. Why is that? Different things that are basically might be causing that the path is going to be different, like skin fractures, like the way how your hair is aligned at the particular moment is making that this particular drop might go a different path. So this is basically a chaos. And we won't be talking about equations, things like that, but there is a guy called Edward Lorenz who was working on predictive models of weather. And he came up with a very great term that you might have heard already. And actually, there is also a movie with the same title called Butterfly Effect. Butterfly Effect is basically saying that if there is a butterfly somewhere and he flaps his wings, then it might cause a hurricane in some other place on Earth. So basically, each system, and we are not only talking about engineering systems, softwares, we're talking about nature, in general, different kind of systems, every system is in fact chaotic. Even if we think that we can predict something, like with the weather, I guess this is a great example. We think we can predict weather, and we are doing some models, we are trying to guess the weather, but in fact, we are not 100% precise with that. And you can see also a nice quote, which is a kind of describing chaos in terms of nature. So chaos was the law of nature and order was the dream of man. And actually, if you look at that, that's true. Nature is very chaotic. Even if you think that it's going to behave in a particular way, it won't. Because there are so many things that are affecting different kinds of ecosystems in the nature. And the order is the dream of man. Look at cities, look at what people are trying to do. We are trying to have some order. Even with the weather, we would like to predict it. We would like to know what is going to happen. That's something that we as a people are doing. So, in a one sentence, chaos theory is all about chaos in different systems. So basically, even if we think that system is predictable, it's in fact chaotic. Now, how it works in terms of IT, how it works in terms of different software. Now, if you think about the software you're writing, the system you're maintaining, you can, in fact, have two groups of things that might influence how your system is going to behave, or how your system is going to be written, or how your system is going to be maintained. One group is all about technology, something that is not human-related, like your servers, the frameworks that you have used for building these systems, etc., etc. The second group of things that are influencing the way how your system is going to look is basically related to people. So you have a development team, you have a stakeholders, you have a product owners, you have different people who are going to be using this system, and different people who are basically giving money to build this system. So two main groups. Now, if you think how you build the system, and if you look and concentrate, let's say, on particular group of people like developers. Development team wants to build some software. Again, there are different factors that are causing that the system might be looking and behaving in a different way, like the methodology that has been chosen to build that software. It can be waterfall, it can be agile. Different kind of agile methodologies. That's the one thing influencing the system that you're going to build. Second thing, the architecture of the system. Usually, when you're talking about architecture, you have some architects. Yeah, there are some discussions how to build the system, how we can tie together different components, and final decision again is based on different factors, like the experience of the people who are talking about this architecture. When they were working, in which mood they are, because depending on that, they might choose a different approach. Even the article that they have read just day before the discussion, this also might influence how your software is going to look like. So this is basically saying that even the software systems, software solutions, even if we think they're predictable, they're in fact not. And chaos engineering is a way of introducing chaos to your system. Why we would like to introduce chaos to our system? Because we would like to prepare for unknown. That's the whole concept. So let's think about that way. You build some great software, great service that should be working 24/7. There is a weekend, there is a Saturday, and you go to sleep, and in the middle of the night you get a call. Yeah, there's some problem. You have to wake up. You have to fix it. Wouldn't it be better if your system would heal itself? Probably it would. We're gonna see in next slides that there are different kind of disruptions that may happen for your services, for your systems, and they are really, really hard to be predicted. So chaos engineering gives you possibility to introduce disruption to your system, to observe your system, to react, to see how it's going to behave, to fix problems, and then reiterate once again the same approach. And chaos engineering, in fact, is not about causing problems. Chaos engineering is about revealing problems. Disruptions, which are controlled by us, are really giving a possibility to reveal the problems. And this is, of course, a nice quote by Nora Jones, who is a senior chaos engineer at Netflix, that you can see on the screen, saying exactly that. Before you even start thinking about introducing chaos engineering to your organization, you have to think about fundamentals. That's very important. And this diagram you can see on the screen, it's saying about, it's talking about microservices, but of course it can be applied to any system. And as you can see on top of it, first of all, let's focus on foundation. Let's think if your system, your service, your application, is it ready to be, published to a public world? Have you fixed all bugs? Of course, we cannot probably fix all bugs, but there must be some level at which you decide, yeah, my app is ready. I can give it to people and they can start using it. So this is basically a fundamental thing that you should do. Then, if you reach that threshold, that's great, that's awesome. What you need in terms of thinking about chaos engineering, you need to have something that we call steady state. What does it mean that my service is working fine? That's the question that you should ask. What kind of metrics I should be checking to make sure that my system is in a steady state? Of course, there should be a traffic, there should be some customers using the system, so basically normal operation world. But you need to define some metrics that allows you to say, yeah, I have this particular level of, latency in the system, and this is fine. That's my threshold. This is a steady state of my system. So different KPIs should be defined to do that. And of course, to gather all those metrics, you need to have some observability in your system. So you need to have in your organization some tools that allows you to observe your service, your system, your application. Once you have a steady state, then you can think about chaos engineering. This is your baseline. You're starting with a steady state of your system. And the typical process of doing a chaos engineering is defining the steady state. Then what you do, you define hypothesis. And it can be very simple. And from the beginning, this hypothesis should be concentrated on a very small piece of your app or your application or your service. So let's say you're doing hypothesis. If one of my servers is down, my application still is going to be serving content for customers who are using this application. That's it. That's the hypothesis. Then you make experiment. So you actually kill one of your servers, depending on, of course, the tooling you're using. It can be done different way. Then you verify if your hypothesis was right, and you just learn. You observe, you see if there are some problems, something that can be improved. You're fixing, you're improving, you're making it better, and then you're coming back to hypothesis phase, and you're trying to define hypothesis that is reaching a little bit wider part of your service or your application. So basically, you are increasing the radius of the damage that you would like to do to your system. And that's a typical chaos engineering process that could be introduced. A few words about history of chaos engineering. In 2008, Netflix was quite a young company at that moment. They suffered a very, very famous and very tough outage. If I recall correctly, they were down for 3 days. And you're going to see on the next slide how much impact it might have for the business. So, and that was the moment when they decided that, hey, we would like to go to cloud. We would like to go to AWS. And they basically started this transition. And at the same time, they started thinking how we can prepare for all of that happened at that moment. And that was the moment when chaos engineering has been born at Netflix. Of course, there were different people doing probably chaos engineering before Netflix, but it was not, that popular, that formalized. So what Netflix did, they started working on some tooling, and also they started changing the mentality of the people working in their company, so they can start thinking about chaos engineering. And the first tool that they came up with was a very simple tool called Chaos Monkey. And you can think about Chaos Monkey, like you're taking a monkey, you're giving it a gun, you're putting it to a server room, and the monkey is killing your servers randomly. That's it. That's what this tool was doing. And then they were, of course, doing all that process of chaos engineering that we've been talking on the previous slide. And it was very successful. So they started developing more tools, more monkeys, actually. They developed a tool called Chaos Gorilla, Chaos Kong, and eventually they created something that they called Netflix Simian Army. They put those tools on the GitHub around 2011, and over the time, more and more companies started thinking about chaos engineering based on the great success of Netflix in this area. There were a couple of books. There was a conference, first conference actually organized by founders of Gremlin in 2018. And the Gremlin, by the way, why I put it on this timeline, because this is a quite important tool. Why is it important? Because it was created by guys who used to be working for Netflix on chaos engineering. So basically they build it on fundamentals of what they've learned there. And of course, I also put there on this timeline AWS Fault Injection Simulator because we are going to be talking about it. So in 2020, AWS introduced this service to their cloud offering. So this is a very brief history of chaos engineering. And now one of the purposes of this presentation that I mentioned is about why we should be doing chaos engineering. So first of all, resiliency, of course. That's very obvious. We want to have resilient systems. We, as a developers, we would like to sleep at night knowing that our system is going to heal itself, even if there is some unknown disruption. And of course, it won't happen because we cannot have a system that can, just survive everything. Let's face it, yeah. But we would like to have some level of confidence in our system. So this is about resiliency. And don't only think about resiliency of the system in terms of that your system can heal itself, because chaos engineering is also revealing things that are a little bit outside of particular piece of software, because it also reveals how your organization is reacting on the disruption, reacting on the problem. It won't be like that your system is going to heal itself in 100% cases. So in some cases, manual intervention is needed, even if you apply chaos engineering successfully. And each experiment of chaos engineering is showing you how you're going to react as an organization. Are there any procedures defined for disruption? How long is going to take from the moment that your system is down to make it operationable once again? Are there any people on call who can do that during night, etc., etc.? And what you can see on the screen here, above the resiliency word, is actually a couple of charts from the downtime detector service. And those particular charts are, of course, about different kind of systems and websites, like McDonald's, Disney Plus, etc. And you can see a nice red peak at the end of each chart. This is actually, I guess, the latest big outage of AWS. It's from 2021, 7th of December. There was an outage caused by one of network devices problems. At least this is what AWS is saying. And it caused massive disruption for different websites. Like Ticketmaster stopped selling tickets for Adele 2022 tour because of that. Which, you know, if you're a fan of Adele, that's a problem for you. Netflix, they have lost about 28% of their traffic, even if they're having chaos engineering applied. So, you know, you can say 28%, pretty big. On the other hand, if they won't be having chaos engineering, I can bet that it would be even worse. So resiliency is the one thing. But now you can have, you know, someone from a company coming to you from finance team and ask, okay, but you know, we have to invest to introduce chaos engineering to organization. So let's talk about money. Explain me how it's going to help our company in terms of money. And you can think, I like to think about chaos engineering as a kind of insurance policy, something like that. So basically, you put some money. Of course, you need to introduce a new concept, new tooling, you need new people, that's okay. But now think about all the money that you can save. And what you can see on the screen, I don't know, it's visible. Okay, that's fine. So you see two charts for 2019 and 2020 saying about the cost of 1 hour of downtime for different groups, divided to different groups. And of course, the cost of downtime, it depends a lot on the business you're running. If you're a shop that is selling something, it might be a little bit bigger than, let's say, some kind of McDonald's website, yeah? Which is only showing some information, although I can guess that you can probably also order some McDonald's food through their website. So maybe this is not the best example. But still, it depends a lot from on the business you're running. And if you can see on this chart, for 2019 and 2020, for about 25% of companies, 1 hour of downtime cost between $300,000 to $400,000. It's a lot, I would say. And if you're not lucky, you're in this 15-70% of companies where you have a downtime causing you that you're losing every hour more than 5 million. That's a pretty big number. So, you know, talking about money, you can always use that kind of data. And if you think about it in a scale of minutes. Like let's take this $300,000 per hour. If you divide it by 60, you get what, $5,000 every minute. Now, if you calculate it to PLN, I would like to take that money to my pocket rather than spend it on downtime. So that's all about money. And in the end, all of that is about success. Like, success can be defined differently. If you're talking with CEO of some company, probably this is gonna be something that you're gonna be talking about, because success can be defined in a different way depending on the business you're running. It can be about money, but any downtime is also causing that you're losing trust, you're losing potential customers. So let's say I'm a guy who would like to buy something in some shop, and I'm comparing some offers. I have some tabs opened in a Chrome or any other browser, and I want to buy something because on this particular shop, this is the cheapest option. And suddenly website is down. And I have other options which are a little bit more expensive, but only a little bit, open in a different tab. Now, what I would probably do is that I would just, wait 10, 15 seconds, maybe a minute, refreshing the website where I wanted to buy this particular piece of stuff. And if it's not up, I would probably go to another shop buying there, because the difference of price is very small. Now, the next time, probably I won't be coming back to the cheapest shop because I already bought something in the other one. So now someone who had a downtime has lost one customer. If you have a big scale, this is really making a difference. So why chaos engineering? Resiliency, money, and overall success of company or organization. Few words about tools, and then we're gonna jump to AWS Fault Injection Simulator, so FIS. There are plenty of tools out there. very specifically, most of the names are having chaos somewhere in the name. So you have a chaos mesh, chaos toolkit, chaos blade. And there's also Gremlin that I mentioned previously. And of course, today we're going to be focused on AWS FIS. One interesting thing in terms of cloud providers, if you look at the three biggest cloud providers that we have out there, so AWS, Azure, and GCP, AWS is having FIS, Microsoft is having Chaos Studio, GCP is having nothing. Like, they didn't came up with their own tool that allows you to do chaos engineering experiments. I don't know if they're working on something, but even Alibaba Cloud, which is very, maybe not that known, well known in Poland, is having Chaos Blade. This is their tool. So, what is AWS FIS, Fault Injection Simulator? Basically, this is a service, fully managed service that you can use to do your chaos experiments. It's very easy to get started. We won't be setting up, on the next slide I'm going to give you a small demo, but we won't be setting this up from the beginning. The documentation is well written, so it's quite easy to do. Very important thing, it's not faking, it's not simulating disruptions to your system. It's really doing disruptions. So if you're going to say, hey, kill this EC2, kill this server, it's going to kill it, it's going to terminate it, it's going to stop it. So remember about that. You're not faking something. You are really doing damage to your system. But of course, there are some safeguards. So you can also set up and define some metrics that are going to be observed during the experiment that FIS is running. And if some metric is really bad, then FIS can basically roll back all the changes that it did to your system. So there are some safeguards that you can define. Three main components of AWS FIS: actions, targets, experiment templates, and experiments itself. Actions, very, very easy thing. Basically, things that you would like to do to your system, like termination of EC2, like API failovers, like stressing CPU. So things you would like to do, disruptions you'd like to do. Targets, very easy. Resources in AWS against which you are doing those actions. Now, you combine actions, targets, and safeguards into something that we call experiment template. So you're creating experiment template, you define actions, targets, safeguards, and additional parameters, and then you run experiment based on this particular template you just defined. I guess this is very easy, and you're gonna see that indeed this is really easy to do. One important thing about actions, I mentioned that FIS can kill you, terminate your EC2 instance, it can stop your instance, start your instance, etc. It's a quite young tool, I would say, so don't expect that there are too many actions already defined there. I hope there are gonna be more. We can say that there are a couple of categories where we can find already defined actions. So EC2s, that's the one category. The second, a few actions related to ECS, EKS, and also DB. However, you can define your custom actions using integration with SSM agent. We won't be doing that, but I would like you to know that even if there is a limited choice of actions defined in FIS, you can do your own, you can write your own actions when you tie together FIS and SSM agent, let's say for your EC2 instance. So now coming to some example, and actually I have two more slides. I told you that it's going to be a very simple system. we're gonna be testing. Why is that? Because I like simple things, and I guess this is the best thing to explain different stuff. And actually, you might be really surprised how many websites are running using the first architecture when there is only one single EC2 serving some website. That's it. So what we're gonna do? We're gonna quickly set up the first architecture, deploy it to AWS using Terraform. Then we're gonna create experiment template in FIS, define experiment, run experiment, observe, and then we're gonna improve a little bit our architecture We will see how much time we're gonna get, but maybe we can do all 3 cases where in the second one where we have ALB in front of 2 EC2s, and the last one, of course, with auto-scaling group. One thing here, it might take a while, especially when it comes to creating ALBs. So if it's taking too long, I'm gonna be jumping to the last slide where I have a little bit different architecture and real world example of piece of the system that we are using in our company. We won't be testing this particular architecture, but I would like to tell you about the history that chaos engineering would save one of the team's stress, money, nerves, if it was introduced soon enough to the process. So I'm going to be jumping a little bit from slide to slide. So let's first deploy the architecture that I've just mentioned, and we're going to use for that a very simple Terraform code, which is basically going to deploy some security group, which is opening ports 80, 80, 80, and 22 in case of we need, SSH and do some debugging. We're going to deploy AWS instance, and this AWS instance is going to have a tag called name with some value EC2-1, and we're going to use this tag actually to tell our FIS experiment to kill this particular instance. One more thing to add, we also have some script, very simple, that is going to be run. It's going to install Apache, it's going to start it, and going to put some content. So we see something different than a typical Apache website. So this is what we're going to do right now. I'm already logged into AWS console. So let's see that we don't have any instances running, as you can see here. And now my code should be here, I hope. Yes, it is. So let's do Terraform apply. Let it think for a moment. And hopefully, very soon, we're going to see our EC2 instance deployed. I hope it won't take a lot. Okay, let's check what we have in our AWS console. Okay, we have one instance running. So now what we can do is that we can, of course, my script is also giving me a public IP address of this particular EC2. So and it's HTTP, it's not safe, so sorry for that. I didn't have the time to. I guess the simplest solution, the better when it comes to showcase. It's probably installing right now. Apache is installed, and we see that we have a new default website. So we have a website. Yeah, that's it. Very simple. What we're gonna also do is that we're gonna set up some command of curl, so we can watch this particular IP address. Sorry, I made a typo. Okay, and we see 200. Very easy. So now let's do some chaos experiment. Let's go to AWS FIS. And now what you can see here on the left, you have experiment templates and you have experiments. And now, very important thing about experiment templates, you can define them in a console. That's the one thing. The other thing, you can just write your CloudFormation code, and you can prepare the template basically using that approach, and then upload it here. So there are 2 ways you can do that. Actually, I have created yesterday a template, and to be honest, creating or updating template, it's basically the same, so we can do both ways. We can either update existing one for this example, or we can create a new one. So basically what you do is that you put some description, FIS, GeeCON live. And then I mentioned that it's very easy to set up FIS. Yes, it is indeed. The one thing that you should do is that you should define an AM role. And this AM role should be tied with particular policy to allow you to, so basically FIS can interact with resources you would like to destroy or do something with them. So in our case, I previously created AM role, which is having permission to start, stop, terminate EC2 instances because this is what I need. If we are going to be talking about some kind of different resources, your AM role and the policy that you have should allow FIS to interact with those resources. I mentioned about components previously, so as you can see, we have actions. So let's have an action called terminate EC2, and then you can choose from the actions that you actually have defined already in FIS. As I've mentioned, don't expect too much. There are additional things you can do using integration with SSM agent, as I mentioned previously. So you can then stress your CPU, stress your memory, and different stuff. You can also define your custom disruptions there. But yeah, this is what you have. This is what you have out of the box. So let's say we want to terminate the instance, and now of course you have to define some targets, and targets you define below. But by default, FIS created you some name. So let's hit save. Let's see what we have in our targets. We have nothing defined, and what we're gonna do here. We have a resource type already defined. This is EC2 instance. We're going to use our tag called name to select particular EC2s that we would like to kill. So now let's hit save, and here we can define stop conditions, so safeguards. We won't be doing that. We don't need that for this simple example, but you can integrate, let's say, with some CloudWatch alarms. So during the experiment, some events are going to be observed. And as I mentioned previously, experiment is going to be stopped if there is some threshold reached, and the experiment is going to be rolled back. You can also integrate with S3 and CloudWatch logs to send some additional logs that you would like to see. Of course, we don't need that here, but this is also what you can do in case you would like to really see what is happening during your experiment. So we have an experiment template. We have to confirm that we would like to create it, and each action that you're going to be actually doing with either experiment template or experiment itself have to be confirmed, because this is really doing something with your system. Yeah, this is really is not faking. It's really doing disruptions. So we have our template. Let's check if our website is still working. Yes, it is. Carl is also saying that it's working. Awesome. Let's now run this experiment. So you hit start. You confirm. And you wait a little bit. It's still pending, but we can also check what is happening with our instance. Yeah, it's still live. It's not running. Why it's not running? Because it's shutting down. Why it's shutting down? Because experiment is probably, it's completed. It's actually terminating our instance. And now what is happening? Our website, of course, is not working. Yeah, that's something that you can expect. So yeah, you just did your first experiment. You made some hypothesis that if you kill terminate EC2 instance, that your website basically won't be working. And since we have 10 minutes, and there might be some questions, I guess we're gonna jump right into the third architecture, and we're gonna just deploy it. So the third one, just for the record, was about having architecture to improve resiliency, where you have ALB and you have auto-scaling group, and basically that should make our resiliency a way better than we had with the single EC2 instance. So let me first destroy any leftovers. Of course, my EC2 is not there, but there is a security group and things like that, and I would like to have a clean environment. So let's do that. And now let's move to to Terraform code where we have defined, first of all, security group as well. That's the one thing. It's exactly the same as it was for previous example. But instead of defining resource for EC2, we are having a launch configuration, which is using more or less the same setup as it was for EC2, including Bootstrap. 2 subnets, ALB, some ALB listener, target group, very simple stuff. And of course, auto-scaling group, where we are saying we would like to have at minimum 2 EC2 instances running. And we're also adding the same tag as we added previously. So in fact, we don't have to create once again experiment template. We're going to be reusing exactly the same. We're just going to run a new experiment against our improved architecture. So let's now go here and let's do Terraform apply once again. And probably it's going to take a while. Yesterday when I was trying it, it was like about 3 minutes, especially creating ALB, load balancer. It was taking a while. So let's give it some time. And in the meantime, as I mentioned previously, I'm going to jump to the last slide that I have that is having some content. Titled Chaos for the Rescue. So you see a little bit more complicated architecture. Also, this is not rocket science. Yeah. So the system that you can see here is actually one of the systems that has been re-architected a little bit, at least one of layers by one of teams in our company about 2 years ago or something like that. Very shortly, web nodes you can see here are doing some processing of the data that are coming from the outside. Those data are generally some performance alerts, which are then correlated, interpreted by the code that is running on web nodes. And previous architecture was not including SQS that you can see here, so queuing service for that AWS provide. Was not having Lambda, was not having S3 buckets. So after introducing those changes, the whole concept was that if by any reason web nodes are down, we won't be losing data, yeah? Because previously we were losing data. There were no queuing, data were not queued, and basically thrown out. So what has been introduced, Lambda, that is doing some small processing, then the message goes to SQS. If it's too big, the only reference goes to SQS, and the actual message is going to S3 bucket, and then web nodes are having some listeners and just, getting those data from SQS and processing. And when the team was designing this architecture, they really paid attention to different details. Yeah, they really tested it very well. They really took into consideration the amount of load that production is having, as well as a couple of spikes, because the system is having spikes of data through a day, which are happening at the same time. And everything was working perfectly. Everything was working really great. And then this code was deployed to production. And it was working fine until the morning next day when there was a spike. A spike was expected because, as I mentioned previously, the system was tested for the spike. But suddenly, we lost a bunch of data because of the throttles on Lambda level. And if you read documentation of AWS, there is a particular number of Lambda functions running at the same time. Now, this is in a different context, but one of the contexts of a number of those Lambda concurrent executions is in context of AWS account. Now, what happened is that when the system was tested, of course, it was tested on RDS account, and everything was fine there because we were not reaching the limit. But on the production account, there were also other systems. It was not, isolated for this particular service. So it came up that there are different systems using Lambdas, and basically we hit the limit for AWS account, throttles, no data. If chaos engineering was introduced earlier, and of course, that's the very important thing. We lost the data, so system was not prepared for that situation. If chaos engineering was introduced earlier, the system probably could heal itself somehow. And in this particular moment, when your team realized that there is a problem, of course, there's loss of nerves. People had to sit down, think about some kind of temporary solution until we really fix that in a different way, etc., etc. So very stressful situation, which could be avoided. Now, coming back to our example with improved architecture. Let me see if we have all resources there. Yep. All is there. Let's really see how it looks like from instance point of view. Actually, yeah, we have 2 instances. That's awesome. Let's now see if we have a load balancer. Do we have it? Yes, we do. So instead of hitting particular EC2 instances, what we can do is, of course, we can hit the load balancer. We have our website, that's awesome. And let me do some curl to watch it, sorry. Once again. Okay, it's 200. And now, let's run the same experiment that we ran previously. Where are my templates? Let AWS think for a second. Is anything else working? ONNET is working? It's not working. Yeah, there's a problem. I guess general. Okay, yeah, it's back. It's back. All good. So let's start this one once again. As probably as you can, predict, probably our 2 instances are going to be killed because they're having this tag with a value with name and the particular value which is the same for each instance. However, and what is going to happen? That our website is still down. So, did we achieve our resiliency goal? If we're going to wait a little bit, expectation is that the website is going to be back. And it's going to be back, of course. But as a customer using this website, I would... So let's think about this for a second. Yeah, we did everything that could be done to provide resiliency because we have ALB, which can redirect requests. We have auto-scaling group that should spin off a new EC2 instances where in a moment when there is no EC2 instances, we said we want 2 EC2 instances. And even then, once we killed all EC2 instances that we had there, we still don't see our website running. Now, who can guess what it reveals? It's very simple again. Why we did wrong? We did everything. Yep. I heard something. We did everything right. The only thing that we did wrong is that we didn't set a proper value when it comes to how often auto-scaling group should be checking whether there are some EC2 instances running. Yeah. So those EC2 instances are going to be up there soon, right now. But let's wait a moment and refresh. And the content is going to be again successfully served, but they are not there. So this is again one more problem we just found using our chaos experiment. And to be honest, that's it for me. Questions. Let's see if we have some questions. Whoa, so much questions. Do we have time for this?
We should try at least answer to the most voted one, at least.
Which one? First one. AWS zone outage. One of those chaos Simian army tools. I don't remember which one actually. It could be either Chaos Kong or Chaos Gorilla. I don't remember which one. I guess one of those is really simulating AWS zone outage. Another one is even simulating, I guess, whole region outage. So I guess that would be the best way to do that. Why it's called simulator? I have no idea, to be honest. I don't know who came up with the name, but yeah, it's not doing any simulations. It's really doing damage to your system. So, in general, if you're not feel comfortable doing, because chaos theory assumes that you do that on production, all those disruptions. But if you don't feel safe enough to do that on your staging or RDS account. So I don't have an answer to that, to be honest. After we finish, we cannot revert. But as I mentioned previously, you can set up safeguards. And if during experiments the safeguard is reached, the stop condition actually that you saw, if this is reached, then all the changes are going to be rolled back. But this is the only case. If once the experiment is finished, you cannot, kind of roll back. Does chaos engineering fit better system with or without human in the loop? Actually, it fits both. I guess it doesn't matter, what kind of system we are talking about here, because chaos engineering is, as I mentioned during one of slides, it's showing weakness of your system and weakness of the organization you're working with. So yes, EKS nodes, actually there is one action that you can use. I don't remember what it was about, but you can do something with EKS. So there is one scenario where FIS is really useful in terms of that. In terms of serverless, yes, that's a weakness of FIS. I really don't like the fact that you cannot easily do something either with Lambda. With Aurora, actually, there are some actions when it comes to RDS. We can check that in documentation. So yeah, it can do a little bit with Aurora, if I recall correctly, but no things like that when it comes to Lambda. It could. Now you should think about what kind of disruption you really would like to introduce to your system. I'm not sure if I understand the question correctly. If we are talking here about services, native services that are provided by AWS for machine learning, or we are talking about EC2s doing this machine learning. If this is about EC2s, FIS is really helpful. When it comes to services provided by AWS, I don't think it's really gonna help here. Yes, there is. When it comes to RDS, there are some actions. Again, I don't recall it from my head, but we can check that in documentation. There are, I guess, 2 actions that you can do against RDS. Network. Again, custom code for that. You don't have this provided by default. You have to integrate FIS with SSM agent that is running at, let's say, in your EC2. And actually, there are some commands already defined. One is simulating higher latency. But if you want to do something more sophisticated, you can write your own code. Let's say you can write a code that is interfering your ACL, for example. That's the one thing you can do. Does it cost? Yes, it does. That's the simple answer. Okay. I guess we have everything. Thank you, guys. Have a great Friday and weekend.